Welcome learners and viewers in the series of course on topology. In the previous video, we have seen a theorem wherein we have proved that if f is continuous, then f is a function from a topological space Z to the product topology x plus y. F is continuous if and only if the component functions are continuous, right? So in this video, we will talk about the pasting lemma. Let's go for pasting lemma. Pasting lemma. What it says, just put that out here. What it says is, suppose you have a topological space X and another topological space Y. This is Y and this is X. And if you have two closed sets of X such that X is nothing but the union of A and B. So this is A and this is B, and X is the union of A and B. F is a function from X to Y. Better let me change the colors, that will be helpful. F is a function from X to Y. Now it says if you restrict your function to A and B, so f restricted to A will be a function from here to here. This f restricted to A, and let us in the another color, this is B, and f restricted to B is a function from here to here. Okay, from B to Y and from A to Y. If these restriction maps that f restricted to A and f restricted to B are continuous, then we can say that f is continuous, and that's what all about pasting lemma. Okay, so let us state what is pasting lemma, and this is the explanation for this. Alright, so let the statement, let A and B be closed subsets of X such that X can be written as A union B, and f is a function from X to Y. So X is a topological space and you have two closed sets in X such that X can be written as A union B. F is a function from X to Y, such that if you restrict f to A and if you restrict f to B, then both are continuous functions. Okay, then conclusion, then f from X to Y is continuous. Okay, and to prove this, what the data what we have is, we have two closed sets in X. Okay, and if you remember, we have already proved the equivalent statements. In fact, we have proved the 4 equivalent statements to prove something is continuous. And for this proving this pasting lemma, we will use one of them. That is, we will show that the inverse image of the closed set in your codomain is again a closed set in the domain. So we are going to use that definition of continuity of function. So to prove this, let us take a closed set in Y. So let us take C subset of Y be closed in Y. We need to show that the inverse image of this C is closed in X. This is what you have to show now. And the hypothesis, the data what we have is F restricted to A and F restricted to B both are continuous functions. So if F restricted to A is continuous and C, let us take C here, this is C. So F restricted to A is continuous, C is closed, that means the inverse image of this F restricted to A inverse image of this closed set will be closed in A, and this F restricted to B inverse image of C will be closed in B because both are continuous functions. So let us put that. Now since F restricted to A and F restricted to B are continuous, and C is closed in Y, implies the inverse image F restricted to A inverse image of C and F restricted to B inverse image of C are closed in A. This is closed in A and this is closed in B respectively, right? And we know that A and B are closed in X, and we have proved that, or it was given as exercise to show that if A is closed in Y and if Y is closed in X, then A is closed in X. And similarly it holds for open. If A is open in Y and Y is open in X, then A will be open in X. Now what we have, this is closed in A and A is closed in X, so of course this will be closed in X, and this is closed in B and B is closed in X. This implies this will be closed in X, and hence let me write directly, we can put up 2 points here. Hence closed in X, this is because slow. This is because just now we have stated that both A and B are closed in X. So since both A and B are closed in X, we can say that as A and B are closed in X, and these are open in these are closed in A and B. Now let us see what is the inverse image under that. Now F inverse of C will be nothing by definition set of all x in your domain such that f of x belongs to C. And we know that this x can be written as A union B, so it is nothing but set of all x belonging to A union B, because x is nothing but A union B, such that fx belongs to C. So this set can be split into two. This is union, that is OR. So this can be written as set of all x belonging to A such that fx belongs to C. Union means OR. This can be written as set of all x belonging to B such that fx belongs to C. And if you notice, this is nothing but f restricted to A inverse of C. Union, this is nothing but f restricted to B inverse of C. And we already stated that this is closed in X, this is closed in X, and hence we will say that which is closed in X, because this is closed in X, this is closed in X, the union of two closed set is closed, so this is closed in X, and hence f inverse of C is closed in X. This implies, or hence, f is continuous. And for a simple example, let us take example from usual topology on R. So example, let us take a function f from Ru cross Ru, usual topology, and let us define that function fx to be set of all x such that it is x if x is greater than or equals to 0 and 0 if x is less than 0. And if we draw the diagram of this, so it is R cross R. If we see this so this is R cross R, and for all x which are greater than or equals to 0, the definition of it is x. So it will be a straight line like this, y equals to x. Even x equals to 0 is included, and if x is less than 0, then it is 0. It is like this. And if you see the definition here, if you put x equals to 0, you will have 0. So there is no break when you go for your calculus kind of things. Okay, but we will use our pasting lemma to say that this is a continuous function. There is no break. That is the meaning of continuity. And to see that, if we check, let us take two sets, one set for this and another set for this. Let us take A to be set of all the points from minus infinity to 0 plus, and let us take another point B to be set to be from 0 to infinity. And if you see here, f this is closed in R with usual topology, and this is also closed in R with usual topology. So both A and B are closed, and if you see the restriction maps, f restricted to A will be this and f restricted to B will be this, and both are continuous. And restriction maps are continuous. Hence, and we see A union B is nothing but whole of R, and hence f is continuous. Okay, we can look out for another examples wherein you can use this pasting lemma and say that the function is continuous. And again, remember, this lemma says if the restriction maps are continuous, then the function is continuous. If the restriction maps are continuous, then the function is continuous. Okay, we can answer if the function is continuous, then what about the restriction maps? Okay, this is simple exercise, and if you remember, we have already stated this in the previous videos. If you have not gone through that, please go and check in the previous videos in the playlist. Okay, and now in the next video we will talk about the inclusion map, and then we will state a very important result, and we will see 1-2 examples of these two. So see you in the next video.